Hello everyone. This video will show how to add fractions using two methods, the LCM method and the giant one method. Now let's go over some examples. This video will show how to add fractions using the least common multiple method. Now let's go over this example. Looking at this example right here, we can see that their denominators are not the same. We can only add or subtract fractions that have the same denominator. So we have to make sure that their denominators are the same. So we're going to find for the LCM of these two numbers, 5 and 3. So to find the LCM of 3, we just go ahead and count by 3. So I'm going to go ahead and write that down here. So that would be 3, 6, 9, 12, 15, 18, 21, and we can have more numbers of that. LCM of 5 means we count by 5. So we start with 5, 10, 15, 20, 25, 30, we can have more. When we say LCM, we're going to find the number that is common to both of these lists. So we can see that the common value is 15. So 15 is the least common multiple of 3 and 5. So what we do is this will serve as our common denominator. So 15 is the common denominator for these two fractions. Now what we do next is we are going to first divide this 15 by 3. So 15 divided by 3 is 5. And then 5 times 2 is 10. So the first number that we're going to have here will be 10. So again, what I did, 15 divided by 3 is 5. 5 times 2 is 10. And then we have a plus. So we're going to put a plus here. And then we are going to do the same thing again on the other side. 15 divided by 5 is 3. 3 times 4 is 12. So I'm going to write 12 down here. So we go ahead and add 10 and 12. So that would be 22. So that is 22 over 15. So this is the sum of these two fractions that we have up there. Now let's have another example. In this problem here, we are given three fractions. So we first have to find the LCM of 2, 7, and 4. So when we say LCM, we count by that number. So we're going to count by 2. So I'm just going to go ahead and write that down here. So that would be 2, 4, 6, 8, 10, 12. And then I will continue the rest of the multiples. Now I will do the same thing for 7. So I start with 7, 14, 21. And then I will continue the rest. Now let's count by 4. So that would be 4, 8, 12, and then I will continue the rest. Okay, looking at these numbers here, we can see that the least common multiple is 28. So these numbers are common to both 3. So we go ahead and say that their common denominator here is 28. So I will write that down here. And then what we do next is we do the same thing. So that is 28 divided by 2 is 14. 14 times 1 is 14. So I'm going to write 14 here. And that's a plus. And then we do the same thing. 28 divided by 7 is 4. 4 times 3 is 12. So I'm going to write 12 here. And that's a plus. We do the same thing. 28 divided by 4 is 7. 7 times 3 is 21. So I'm going to write 21 right here. So we're going to add all these three together. This would come out 47 over 28. So this is the sum of these three fractions that we have up there. This video will show how to add fractions using the giant one method. Now let's go over this example that we have down here. If you notice, the denominators of the two fractions are not the same, so we cannot add them together. We have to make sure that their denominators are the same. So I'm just going to go ahead and rewrite these two fractions down here. To add these fractions using a giant one method, we are going to multiply 1 to 2/3. And that 1 will be in a form 5 over 5. So whatever this value here, I'm going to multiply that to the first in a form of 5 over 5, which is actually, we have, because if we do 5 divided by 5 is actually 1. So that's why this method is called a giant one. So 5 over 5 is just the 1. So we're multiplying 1 to 2/3. And we do the same thing for the other one here. We're going to multiply this by 1 in a form of 3 over 3. So that is 3 divided by 3 is actually 1. So then we can go ahead and multiply this across. That would be 2 times 5 is 10 over 3 times 5 is 15 plus 4 times 3 is 12 over 5 times 3 is 15. So then they already have the same denominator. So the answer for this would be 22 over 15. So this is the sum of these two fractions using the giant one method. Now let's have another example. Looking at this example, the denominators are not the same. We get a 4 and a 5, so we have to make sure that their denominators are the same before we can add these two fractions together. So we're going to use giant 1 to add these two. So I'm going to go ahead and rewrite this down here. So what I would do is I will multiply the first one with a 1 in a form of 5 over 5. So that's 5 over 5. And I will multiply the second with a 1 in a form of 4 over 4. So then we can go ahead and simplify this further. We have 7 times 5 is 35 over 4 times 5 is 20. Plus 3 times 4 is 12 over 5 times 4 is 20. So we now have the same denominator. So this is 47 over 20. So this is the sum of these two fractions when added together.